Welcome back to the deep dive. Today we're kind of tackling a really fundamental question. How does a bird get feathers, a lizard get scales? We're diving into your sources, which read a bit like a biology recap, comparing animal features and how they get passed down. Okay, let's unpack this.
Right. Our main goal here is to pull out the core concepts. What exactly does the source mean by a feature? And how does this idea of inheritance work to keep those features going, generation after generation?
Exactly. And the source kicks things off comparing four main groups, humans, fish, lizards, and birds, focusing on really basic things, their limbs, and what covers their skin.
Yeah, it's a neat comparison. You see the differences straight away with how they move. Humans have arms, legs, birds wings and legs, lizards legs and tails. What's interesting, though, is the source says fish have fins and legs. That kind of suggests we're talking broadly, maybe including species with limb-like fins or even early forms.
That's a good point. That detail matters. And then there's skin coverings. The source notes, well, obviously all animals have some kind of skin covering, but the type is all over the place, right? Feathers, scales, fur.
That's right. A huge variety.
So for the listener, these are the basic building blocks the features we're analyzing.
And these physical forms, arms, legs, scales, feathers, that's what the source calls features. Basically, the shape or look of body parts. This whole comparison is really setting up the main question. How does a parent fish pass on the instructions for fins while a parent bird passes on instructions for wings?
Which leads us straight into how things continue across generations. We've got the features. Now, how do we make sure, a human baby doesn't suddenly pop out with scales?
Well, that's where the term inherit comes in. The sources use it specifically for how features from parents get passed to their offspring, their young. What's fascinating here is the emphasis on offspring looking similar to parents. Not identical, but similar, because they get similar features.
Okay. That similarity versus identity thing. That's really important, isn't it?
It is.
Because inheritance is precise enough for a baby lizard to get legs and scales like its parents. But there's still room for small differences, like size, maybe slight color changes between them.
Exactly right. So if you zoom out, the inherited plan makes sure the big stuff, the defining features of the species, like having wings versus arms, gets passed on reliably. You inherit the feature of having fur, let's say, but maybe not the exact same pattern or number of hairs as your parent. It's about the blueprint.
Got it. So this deep dive really confirms it. Passing on these specific anatomical features like limbs or skin type is the key biological process, and the sources call that process inherit. It's why a fish makes a fish, a bird makes a bird. Simple as that, fundamentally.
And it underlines that even though the features themselves look vastly different across these animals, the underlying mechanism, inheritance, seems to be universal among them.
So, what does this all mean for you listening? If these inherited features are about the form or appearance of body parts, think about that similar, not identical idea. Maybe consider one tiny physical feature you share with one of your parents, perhaps the curve of your fingernail or how your hair parts. If that form is inherited, what do the tiny differences between you and your parents suggest about how precise or maybe how flexible that inheritance mechanism really is? Something to observe for yourself.